On the evening of November 4, 2025, the calm of Louisville, Kentucky, was shattered when a UPS cargo plane, a McDonnell Douglas MD-11 freighter, crashed shortly after takeoff from Louisville Muhammad Ali International Airport. The aircraft, operating as UPS Flight 2976, was bound for Honolulu, Hawaii, carrying freight and operated by a 3-member crew. What was expected to be a routine intercontinental cargo flight turned into one of the most tragic accidents in the history of UPS Airlines. The crash occurred just moments after liftoff, and early witness reports described a horrifying scene. A massive fireball, thick black smoke rising from the industrial area near the airport, and parts of the aircraft scattered across several blocks. It quickly became evident that something catastrophic had happened to the plane almost immediately after takeoff, and soon investigators confirmed that the left engine had separated from the wing, a rare and devastating failure that robbed the aircraft of control. The MD-11 is a 3-engine wide-body freighter derived from the DC-10 design. It has 2 engines mounted under the wings and 1 in the tail. The aircraft involved in the crash was more than 30 years old, built in 1991, and had served with UPS for over 2 decades. It had undergone heavy maintenance only months before the accident. On that November evening, Flight 2976 lined up on runway 17R for departure, heavily loaded with cargo and fuel for the long flight to Hawaii. Witnesses said the takeoff appeared normal at first, but as the aircraft accelerated, sparks and then flames appeared near the left wing. Within seconds, the fire intensified, and as the aircraft lifted off, a loud boom was heard, followed by a shower of debris falling to the ground. The plane climbed only briefly before banking left and crashing into an industrial area beyond the airport perimeter. The crash resulted in the deaths of all 3 crew members on board: Captain Richard Wartenberg, First Officer Lee Trout, and International Relief Officer Captain Dana Diamond. The impact and ensuing fire also killed several people on the ground, bringing the total number of fatalities to at least 14. Buildings and vehicles in the crash zone were destroyed, and first responders described scenes of devastation, with burning wreckage scattered over half a mile and flames engulfing structures near the point of impact. Emergency services battled fires for hours as UPS suspended operations at its Louisville hub. Within hours, the National Transportation Safety Board dispatched investigators to the scene. The team quickly recovered both the cockpit voice recorder and the flight data recorder from the wreckage. Preliminary analysis of the cockpit recording revealed a repeating bell alarm that began ringing during the takeoff roll, continuing for about 25 seconds. That sound indicated a critical system warning, likely related to an engine fire or other major malfunction. Data from the flight recorder confirmed that the left side engine parameters spiked, followed by a sudden loss of power and structural breakup signatures consistent with engine separation. According to NTSB member Todd Inman, who briefed the media, the left wing caught fire during takeoff and the engine detached moments later. Investigators found the detached engine several hundred feet from the main crash site, suggesting it fell away almost immediately after rotation. The separation likely damaged the wing's leading edge and fuel system, intensifying the fire and destabilizing the aircraft. The pilots attempted to climb, but could not maintain altitude or control. The MD-11 crashed less than a minute after liftoff. The central question for investigators became why the engine detached in the first place. Engine separations are among the most catastrophic mechanical failures in aviation. They are supposed to be almost impossible in normal operation, as the pylon, the structure connecting the engine to the wings designed to withstand enormous forces. A pylon failure can occur only if there is severe structural fatigue, corrosion, improper maintenance, or damage from fire or impact. The NTSB's structural and materials specialists began examining the engine mounts, pylon fittings, and wing attachment points. They also requested detailed maintenance records from UPS, and from the Texas facility, where the plane had recently undergone heavy maintenance. Investigators noted that the MD-11's pylon design shares its heritage with the DC-10, which was involved in the infamous 1979 American Airlines Flight 191 crash, also caused by an engine separation. That accident led to design changes and stricter maintenance procedures, but after decades of service, fatigue can still develop in critical attachment areas. The MD-11's age, combined with years of cargo operations involving frequent takeoffs and landings at high weights, meant its structure had endured tremendous stress cycles. Initial metallurgical analysis of the wreckage suggested possible fatigue cracking near the pylon's upper link attachment, an area that would have been subject to extreme heat during a fire. Investigators found evidence of a fuel-fed fire that might have started in the engine's accessory section or fuel lines before spreading into the wing root. The fire likely weakened the pylon's structure until the engine tore free. When the engine detached, it ripped through hydraulic and fuel lines, exacerbating the fire and causing rapid loss of control. Witnesses described the aircraft's left engine trailing fire down the runway, and one bystander captured video showing the moment when the engine appeared to separate. The aircraft, still carrying nearly 38,000 gallons of jet fuel, became engulfed in flames almost instantly upon impact. The enormous explosion and secondary fires destroyed several warehouses and vehicles in the impact area. For hours, thick smoke blanketed parts of Louisville as firefighters worked to contain the blaze. The MD-11's flight characteristics also made recovery nearly impossible under such circumstances. The aircraft's design has long been known for its challenging handling, particularly during takeoff and landing. Losing one of its wing-mounted engines not only caused asymmetric thrust, but also severely disrupted the aerodynamics of the wing. At low altitude and heavy weight, even the most skilled pilots would have struggled to maintain control. Experts explained that when a wing-mounted engine separates, the sudden loss of lift, thrust, and structural integrity creates forces beyond what the aircraft's control surfaces can counteract. Data from the flight recorder indicated that after the engine separation, the aircraft rolled sharply left and pitched down. The crew likely attempted to counter the roll with opposite rudder and aileron input, but the left wing's structural damage and the ongoing fire made recovery impossible. Within seconds, the aircraft's speed dropped, and the nose descended until impact. The Federal Aviation Administration took immediate action following the crash. On November 8, just 4 days later, it issued an emergency order grounding all MD-11 aircraft in the United States pending inspections of their engine pylons and wing structures. The FAA cited a risk that a similar unsafe condition could result in loss of continued safe flight and landing. Both UPS and FedEx, the main U.S. operators of the MD-11, voluntarily grounded their fleets. Boeing, which absorbed McDonnell Douglas in 1997, sent engineering teams to assist the investigation and inspection process. The grounding of the MD-11 fleet was a major disruption to global cargo logistics. The MD-11 is a workhorse of long-haul freight operations, and grounding the fleet meant rerouting or delaying shipments worldwide. For UPS, whose main global air hub is in Louisville, the crash and subsequent investigation struck at the heart of its operations. The company expressed deep sorrow for the loss of its crew and the community members affected and pledged full cooperation with authorities. As investigators continued to examine the wreckage, they found that the left wing and engine mount area showed signs of both mechanical overload and pre-existing fatigue. The right engine and tail engine were largely intact, suggesting the primary failure occurred exclusively on the left side. Parts of the pylon structure were found embedded in the wing, while others lay scattered along the runway, consistent with an in-flight breakup. Laboratory testing on recovered fragments indicated microscopic cracks that could have propagated over time. These findings pointed toward a combination of structural fatigue and fire damage as contributing factors. Another area of investigation focused on maintenance practices. Records showed the aircraft had undergone a C-check in mid-2025, including work on the wing structure and engine mounts. The NTSB examined whether any maintenance error or oversight might have weakened the pylon assembly. In prior DC-10 and MD-11 cases, improper reinstallation of pylon components had caused stress concentrations leading to failure. Investigators interviewed maintenance personnel and reviewed quality assurance records from the overhaul facility. Meanwhile, metallurgists studied the recovered bolts, fittings, and brackets connecting the engine to the wing. If any of those fasteners had shown signs of corrosion or wear, they might have been the weak link that failed under takeoff stress. The NTSB also considered whether vibrations or excessive torque could have contributed to the separation. The possibility that the engine fire began due to a fuel leak or ruptured line was also under scrutiny. The cockpit voice recorder provided insight into the crew's final moments. The recording captured the pilots performing routine callouts during the takeoff roll. About halfway down the runway, one of them mentioned a possible warning light, and within seconds, the continuous bell began sounding. The captain ordered an abort check, but decided to continue the takeoff, likely because they were already past decision speed. Almost immediately after rotation, a loud bang was heard, followed by a loss of communication. The final seconds contained sounds of chaos alarms, the fire warning, and rapid roll movement, before the recording stopped abruptly. Forensic analysis of the black boxes, flight data, and wreckage would take months, but the preliminary evidence suggested a clear sequence: a left-wing fire, structural weakening of the engine pylon, separation of the engine, loss of control, and crash. The investigation was expected to culminate in a detailed final report, identifying probable cause and recommending safety measures to prevent recurrence. The Louisville community faced immense grief and disruption in the aftermath. The area around the crash site was cordoned off for days as recovery teams worked amid smoldering wreckage. Families of the crew members gathered at the UPS hub for memorial services. Company officials emphasized the professionalism and experience of the crew, noting that Captain Wartenberg had logged more than 12,000 flight hours, including over 3,000 on the MD-11. While the investigation continued, aviation analysts discussed broader implications. The MD-11 fleet was aging, and although many aircraft remained airworthy, they required increasing maintenance. Some experts suggested that this tragedy might accelerate the retirement of older MD-11s from cargo service, as operators turned to newer, more efficient twin-engine freighters like the Boeing 777F and Airbus A350F. The crash also reignited debate over structural inspection intervals for aging wide-body aircraft, particularly those exposed to heavy cargo duty cycles. Engine separation accidents are among the rarest but most devastating in aviation history. When one occurs, it almost always points to deep-seated issues, fatigue, corrosion, or maintenance lapses that accumulate over years. The Louisville crash shared disturbing similarities with the 1979 Chicago DC-10 disaster, in which an engine also detached during takeoff due to pylon failure, leading to an uncontrollable roll and crash. That earlier accident reshaped aircraft inspection standards for decades, and this one could have a similar effect for the MD-11 fleet. In time, the NTSB's final report will confirm the root cause, but even in the early stages, the evidence clearly indicated that the physical separation of the engine was the triggering event. The investigation would likely recommend more rigorous non-destructive testing of pylons, improved fire detection and suppression in wing areas, and possibly redesign or reinforcement of attachment hardware. For the families of those lost, technical answers can never fill the void left by the tragedy. The UPS crash at Louisville stands as a stark reminder that even with decades of safety progress, Aviation remains vulnerable to rare but catastrophic mechanical failures. It also underscores the importance of meticulous maintenance and proactive aging, aircraft management. The lessons drawn from this disaster will ripple across the industry, prompting carriers, regulators, and manufacturers to ensure that such a chain of events never repeats.